Doodle Physics. Hello girls and guys, in this video we'll talk about dimensions of physical quantities. What are dimensions? So here is the answer. Dimensions are the basic representation of nature of any physical quantity. Let's learn dimensions with the help of simple example. Suppose if we have to measure length, then we have different scales to measure it, like centimeters, meters, kilometers, feet, inches, etc. All these units are describing that in which scale the object is going to be measured. Like if we are measuring a 10 centimeter distance, then it means we are measuring an object in small scale. Similarly, if we are measuring 10 kilometer distance, then it means we are measuring an object in large scale. Irrespective of the scale, we are interested in measuring basic quantity length. Therefore, basic representation of length in dimensions is L. Anywhere, if we find the dimension L, then we will obviously understand that the physical nature of the quantity is length, irrespective of its scale of measurement. As there are 7 fundamental quantities, similarly, each quantity has a specific dimension, which are mass m, length L, time t, temperature K, electric current A, amount of substance N, and luminous intensity J. Now let's talk about dimensions of derived quantities. The dimensions of derived quantities can be defined by using dimensions of fundamental quantities. If you don't know about fundamental and derived quantities, then you must watch our Introduction to Physics video. The link of that video is given in description. So, there are 2 methods to find dimensions of derived quantities. The first one is from formula and the second one is from units. Let's discuss the first method to find out dimensions of derived quantities. For example, if we need to find dimensions of a derived quantity velocity, and its basic formula is displacement over time. As already discussed, the displacement can be measured in feet, meter, centimeter or other units, but its nature is a kind of length, so its dimension is L. Similarly, the dimension of time is t. Now let's put dimension L and t for displacement and time respectively. So we get dimensions of velocity as L over t, or we can also write Lt power minus 1. The second method is to find dimensions by units. Let's take acceleration as an example. The units of acceleration is meter per second square. Since meter is unit of length and the dimension of length is L, and second is the unit of time and its dimension is t. So replace meter per second square with their respective dimensions and we'll get the dimension of acceleration as L over t square or Lt power minus 2. For further understanding and practice, let's find dimensions of other quantities such as momentum. The basic formula of momentum is mass into velocity. The dimension of mass is m and the dimension of velocity is L over t. Now put the dimensions in place of quantity, so finally we will get the dimension of momentum as ml over t or mlt power minus 1. We hope you can find the dimensions of any quantity with the help of our described method. This is the end of this video. If you like this video, then please hit like button, share this video and subscribe our channel. Thanks.